This is the lecture that goes along with Chapter 5 of your textbook, titled Looping. You've been exposed to looping a little bit in previous chapters. I think we've seen an example of a while loop as we were talking through some of the topics. But what we'll do is we'll learn about what looping is. We'll talk about why we have looping, how to use a loop control variable, how we can nest one loop within another. We'll talk about common pitfalls when using loops. We'll talk about a for loop, which is another type of loop in addition to the while loop. We'll talk about when it's often necessary or convenient to use a loop. And then we'll talk about what is the differences and similarities between selection and loops. So basically, looping allows you to execute a block of code over and over again, and then having some value. We talked about sentinel values. When some condition comes true or some value is a sentinel value. I think in one of the homeworks you did, you had a while loop, and it said while basically user input was not the word quit. You wanted to keep processing it or something like that. So if you do things with loops and you process multiple sets of data or different size data, it's going to be more efficient and you're likely to have less errors. So basically, a loop is a structure that's going to repeat a block of code, what they're calling actions, over and over again while some condition continues to be true. When that condition becomes false, then the loop will terminate. So basically, this is the loop structure. You have a question that's asked. If the answer is yes or true, you're going to execute some block of code, and then you're going to go back to the decision point and ask the same question. So while the same question is true, you keep looping through that loop to the right for the true or yes condition. So that's when you're going to have a loop, when you have a flow chart that looks like this. So I'm not a real big fan of the way they do this, where they constantly say, oh, have a subroutine called housekeeping, have something called detailed loop, and then have something called end of job. Maybe a module is appropriate there, maybe it's not. It just kind of really depends on how complex your program is and the block of code. But the textbook uses that over and over again, and technically there's nothing wrong with that. So as we talked about in previous chapters, you might have something called EOF, end of file. And basically that means if you attempt to read a value and there is no additional value to read, then you need to stop execution. We'll talk about file I/O down the line, but this applies to user input, file input, that type of thing. So while we're not at end of file, continue to do the detail loop. So we'll just keep looping and looping and looping until there's no input data and we have end of file. So this is showing you the syntax of a while statement. You have to have the while word. You can then have a condition. It can be a single condition. It can be a single Boolean value. It can be a big string of ands and ors and parentheses, but whatever logic you need. While that condition is true, you're going to have a block of code, which they're calling just statements, that will execute. And then when you hit the end while keyword, which is required, you will go back to the top of the loop and reevaluate the condition. So the one thing you should kind of make mental note of, if you haven't already thought about this, is obviously the block of code that's being executed within the while loop is going to have to be changing values that are used in the condition. So at some point that condition becomes false and you fall out of the while loop. Otherwise, you've created an infinite loop. So if you said something like while 1 equals 1, do a block of code, that block of code would run forever until you manually terminated it or broke out of the program. So we've talked about this. Loop executes while condition is true. We have a control loop variable that's going to be initialized in the case of a while statement before the loop. It's going to be tested in the condition, And then again, as I've stated, something in the body of the loop must alter that value so that at some point in time when you test the loop control variable, it is going to be false. We can do things by running a counter. If we want something to happen 100 times, every time we go through the loop, we increment a counter by 1. When that counter exceeds 100, we're done. Or we can have a sentinel value we've seen before, like while the user inputs a line whose value is not capital quit, then keep executing this loop. When the user wants to quit, they type capital quit, and the loop terminates. They have different kinds of things. A definite loop is something that would execute a predetermined number of times. For example, if you had a loop, it had a control variable called I, and I was going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know that's going to execute 10 times. You know the values of I are going to be 1, 2, 3, etc. A counter-controlled loop is one that counts repetitions, and then you say something like, after you've read 100 lines, terminate. Again, you know how many lines are going to be read, but you don't actually know what the values of the line read is. So you know it's going to execute 100 times, but you don't know exactly for what values. Loop control variables can be altered in a number of ways, more than the two that they list here in the slides, but real commonly incrementing and decrementing are ways to control a loop variable. Incrementing just means adding 1 to a value. Decrementing means subtracting 1 off. So in my example where I wanted to go 1 to 10, I might set my loop variable I to 1 outside. I'll say while the variable is less than or equal to 10, do something, and then typically at the very bottom of the loop I would say I equals I plus 1. I'd go back up to the top. I plan to give you some more tracing examples, videos of me tracing through programs, because that's a very important technique. I will definitely do at least one, if not more than one, using these various types of loop constructs. Here is a definite counter. Just like I said, they want to go through and output 4 times the word hello. So they want to say hello, 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 and then they'll fall out of the while loop, and then they'll say goodbye. So we've got pseudocode on the right, flowchart on the left. Notice that the flowchart has a couple of annotations, which again, actually they have 3, that are the equivalent to comments in pseudocode. For whatever reason, they chose not to show comments in the pseudocode. Probably should have. In an indefinite loop, here, basically you're going to ask the user, do you want to continue, yes or no? And while they continue to type Y, you're going to execute. So basically it would say, hello, do you want to continue? If you said yes, or sorry, if you said Y, then it would say, hello, do you want to continue? You type Y, it's hello, do you want to continue? And then maybe at this point you type no or N, and then you would fall out and it would say, okay, goodbye. So we don't know how many times, if you were really, really bored and wanted to type Y 1,000 times to see the program print hello 1,000 times, it would do that. But we really have no way to know how many times this loop is going to execute in advance, because it's all based upon what the user is going to do. So here's an example of them running BASIC from the Windows command prompt and showing you execution. The user said yes 3 times, and each time it outputted hello. When they finally said no, it said goodbye. So that's kind of a command line driven way to execute your program. The bottom one is a more graphical way where you would click Y, and every time you clicked Y it would say hello. When you finally click the no button, then it would say goodbye. So that's just a couple of different environments. What we're going to be doing most likely will look a little bit more like the first one. We won't be doing it at the command line, but we'll be doing it in something that is line based. So you have an assignment coming up, I believe, where you have to kind of get familiar with that and do a very basic program. You need to initialize your loop control variable. You then need to have a test that tests that loop control variable, and then at some point in your loop, again, often at the end of the loop, you will need to alter that control value. So that's really what happens in all loops. So here is a payroll program showing how, typo, the loop control variable is used. So basically they come through, and in the housekeeping they output some information, and in the detailed loop they ask you for the person's gross pay, they figure out some deductions, they figure out what your net is, they output it, ask for a name, and then it asks what's the name of the next person. If you type in capital quit, your program will terminate. If you type in another person's name, then you will go through that detailed loop again. So that's just showing you an example of where you're going to be looping. This is an indefinite loop because you don't know how many names that the user running this needs to process. Nested loops are putting loops within loops. You talk about inner loops and outer loops. The outer loop is the first one you encounter. It totally encompasses the inner loop or other inner loops. Again, here they're kind of talking about nesting two loops, but you can nest as many as you need to solve the problem at hand. So this one, they're going through, and they're asking you to enter a quiz name, and sorry about that. Enter a quiz name, and then just keep doing that. Within that, though, you need to ask the scores that were made on the various types of exams. So the housekeeping asks you what the name of the quiz is, and then the detailed loop, which they don't have on this page, is going to go through and have another loop in it, which is going to get the score for the various parts. So here you set the part counter to 1. You have a variable parts that tell how many parts there were to the exam, and what you do is you print a label. You ask for the number of questions within the parts. So you go through and get all the questions within the parts in that inner loop. When you come out, you increment by 1 the part counter, and then you go back up the top and say, have I processed all the parts? If I haven't, then I need to go down and get the number of questions within that part. So you go through and do that over and over again. And then finally, you're going to go out, and it's going to ask for a quiz name. If you type capital quit, the program's going to terminate. If you type in something else, it's going to assume that it is a quiz name, and then you're going to go back, and your condition will be true, and you'll go back into this detailed loop. This is the pseudocode. I highly recommend you go back and look through this and make sure you understand it. Nested loops never overlap. That means you can't have one loop and then somehow ask the question for the second loop, but the termination of the second loop is after the termination of the first loop. That will not work. So if you have nested loops, the whole while statement or the whole for statement has to be within whatever that outer loop is. The inner loop will go faster is one way to think about it. If you're iterating the outer loop 1 to 10, the inner loop 1 to 10, the outer loop will be set to 1, the inner loop will go 1 through 10. It'll execute 10 times. You'll come back to the outer loop, its control variable will be incremented to 2, and then you will do all 10 iterations of the inner loop again. So you're over and over again doing that inner iteration, doing all the iterations before you go back and check the control variable or the answer to the outer loop. If you do not initialize a variable correctly, then things are probably not going to work correctly, or you may get at least one iteration of the loop that does not work correctly, or possibly it jumps out of the loop when you check the control value. So you need to always make sure that you input something or set a control variable before you ask the question on the first iteration or the first pass through the loop. So here they're showing you an example of where they're trying to compare something to the word quit, the name, and the name was never initialized or never prompted for. So as we talked about in previous chapter, you need to prime the input or seed the input. I think the book uses the word prime. Prime the loop and have an input name where the little red arrow points to in the flowchart and the equivalent in the pseudocode. Here, the mistake is you're looking for name to not equal quit. You never ask for the name again, so whatever first name you put in will continue to be used over and over again, and it will never equal quit. So in addition to having an infinite loop, it is going to be one that just continues printing hello and the person's name over and over again, and it's going to be the same person. So that's where you didn't alter the loop control variable, in this example, the variable name. You want to make sure that you use the correct comparison. Here's some examples that if you're not comparing correctly, you may overcharge a customer, you may not apply a discount they're entitled to, you may give extra medicine to patients at a pharmacy, you may book too many people on a flight, and all those are going to cause problems for someone if they happen. Here we have one again where we get the person's name, but we basically say, is the name greater than quit? Well, different things can happen in different programming languages. In BASIC, it would probably complain about that. But in other languages, if this is a string value, so greater than would mean it came later in alphabetical order. So, if you had a name that started with R, then it's going to consider that possibly greater than quit and go through and execute the loop. But if you had somebody's name that started with A, then that would not be greater than quit and it would terminate. So basically the wrong comparison is being made. And also you may, both of these were declared a string. So, equal and not equal are the two that you're typically going to want to use when you're talking about string values. Not always, but typically. So here, if you want to discount every item by 30% because you're having a sale, let's say, you don't really need to put that in the loop. That's something that's constant. It can be outside the loop. Otherwise, you're doing the same calculation over and over again. So just pull anything out of the loop that doesn't need to be in the loop. So here, they're just showing you that this is in the loop. It really should be outside the loop. And here it is in pseudocode. So what they've done here is they've made it a calculation at the top. I mean, every time you come into detailed loop, you're going to have a new price. You're going to have a price. You need to calculate a new price, but then do the comparison and not do that over and over again every time you go through the loop. So here they're showing you the pseudocode of moving that out of the while loop and just making it part of the detail loop. Another type of statement we have is the for loop, and basically what it does is it initializes and evaluates all in one state, the actual for statement, the first line. So on the left, we have a loop variable. We set it to 0, and then we increment the variable at the bottom. That's a real common thing to do. So they actually, to make it a little more readable, they say for count equals 0 to 3, step 1. So the first time through the loop, the count is 0. The block of code in the for loop executes. When you hit the end for statement, whatever the step is automatically happens. So in this case, we hit the end for, count would go from 0 plus 1, it would go to 1. We would execute the loop again for the count variable equal to 1. So that is a really definite loop on the left, so they actually have a for statement to make it a little easier to understand. If you need to increment by 2 every time you go through the loop, then you would just say step 2. So basically, they're talking through the same thing that I talked through. So the important thing to realize, though, is when you hit the end for, you increment the variable by the step, and then you retest the condition. So both of those things happen when you hit the end of a for loop. You can increment positive or negative. If for some reason you needed to go 10, 9, 8, you could set an increment or a step of -1. If you omit the step, it is going to be an increment by 1. That is such a common thing to do that they're not going to make you type step 1. If you just omit that, the step is going to be defaulted or assumed to be 1. So here is just a quick reference. Again, the for is required, the end for is required at the end. You have a block of code to execute while the expression is true. So you have the expression, which has a loop variable, an initial value, and then an increment or a step value for each iteration through the loop. You can use while or for, whichever you feel more comfortable. You know, if you happen to have a language that didn't have one, then you could always use the other. Most languages that I know of have both the while and the for loop. It is a pre-test, which means the condition is checked before you execute the loop. And then if you have one that's called a post-test loop, it's actually tested at the end. And programming languages, a lot of them have a do while, and some of them have a do until. Perl has a do until and do while both. But what happens is you actually test at the end. They just have a couple of examples of when you might loop and accumulate values. It's typically when you're summing something up or making a total. So what happens is you go through and you say, for example, how much did I make on cell 1? X dollars. Okay, how much did I make on cell 2? Let's run that, add that to my running total. Okay, cell 3, how much did I make on that? Let's add that to my running total. So those are called accumulators because you're adding together and accumulating a total in this example. If you are summing things together, it's going to start at 0. You're going to add or somehow manipulate that accumulator value once for each set of data or each value that is being processed. And then once you finish, it says accumulators are outputted. Well, they're outputted maybe to the user and or to a file, or maybe they're used in a condition of a loop, but they're somehow used. If you're adding up things and just saying, today we made this much money, yesterday we made this much money, that's going to be referred to as a summary report. So here they were taking the other example, which was here's a bunch of houses that were sold this month, and then down at the bottom, it's $1.1 million. So they have a summary. or a running total at the bottom. So that's just an example of what the program might look like. So here is the pseudocode, again showing the accumulator price starting at 0, showing that in the report you are going through and adding each additional price to the accumulated price, and then when you're done you're going to output that accumulated price labeled as a total. So that's just pseudocode kind of demonstrating this. I don't know if we're going to talk about it or not, but sometimes you need a running product. Running products start at 1, and then you are multiplying each time. So if you started one of those at 0, 0 times anything is 0, so you would never change your running product. So running products start at 1, running accumulators start at 0. This is just pseudocode highlighting those 3 points that we talked about previously. One thing you need to do, they call it defensive programming, but basically think about what the user is going to do. In the previous program, how much did the house sell for? Most people are not going to type in ONE space MILLIOM, etc., $1 million and whatever. But if you expect a number, you need to make sure you get a number. If you're asking what month was the house sold in, and they say the 14th month, that makes no sense. You need to validate your data and make sure it's 1, 2, 3, etc., up through 12. One saying that's been around for decades in programming is garbage in, garbage out. If you don't check or validate your data and the user types garbage, that is something you did not intend, then you really do not know how your program is going to handle that if you don't have some error checking or data validation. So basically what they're showing you here is you're asking for a birth month and you're just trusting it. They can say the birth month is 20. And your program would very happily take 20 and try to process that. That might just result in a mistake, and it outputs somebody's birthday as a 20 in it, or it may be something drastically wrong. One example I have is I had 3 employees that were hired one January many years ago, and for whatever reason, the person typed in their birth year is 99, I think was the issue, or they typed their age in as 99. And so basically what it did was these employees were told that through the university we can get relatively cheap life insurance, for a few dollars a month. Well, they got their first paychecks and they took out like $500 or $1,000 for this, quote, low-cost life insurance. Well, the problem was because the person put 99 in there, it thought you were trying to insure somebody who is 99 years old. And, that's not going to generate you a lot of income, most likely, because very rarely do people live over 100 or 110. So, that's probably an example of where somebody should have validated that input and known that we are not hiring 99-year-old employees. They should have checked for a much reasonable value, or at least said, hey, you inputted 99, are you really sure this person is 99? And gone from there. So here, basically what happens is you have a loop that you're going to be stuck in, or that the user is going to be stuck in, until they give you a valid month. If they give you an invalid month, you just keep asking them over and over again. You probably would want to put in your prompt, hey, that's not a valid month, please enter 1 through 12. But that's showing you how you would validate a birth month, for example. You might want to count how many times you're reprompted. I know I probably shouldn't tell you this. In one of my first programming classes, I already knew how to program, and we were writing a Pascal program that was supposed to ask the person for something. And I had a loop counter that, if it gave them the error message or reprompted them 20 times, it said something not so nice like, don't use this program until you figure out how to read or something like that. And my teacher wrote a note that I should probably be nicer to the end users. But you really should count. If they can't enter a birth month in like 5 prompts, especially if you're explaining to them, you probably want to terminate the program or give them additional help or something like that. Say see your supervisor to learn more about inputting data or something like that. So here what they've done is they've added a count and a number of attempts. So if you wanted to have the person be reprompted 5 times, you would change that 3 to a 5. So you initialize it, and then you add a condition that says, in addition to everything else I'm checking, if counts is less than attempts, then yes, I want this to be yes, I want it to be true, I want to execute the loop over to the right. But if the count gets greater than 3, then that expression is going to be false, and that loop is going to terminate. So it will give them 3 attempts to get it correct, and then the loop will terminate. There's several methods that are built into a lot of programming languages. So you might have is numeric. So if you ask them for a month and they typed in December, you could say if not is numeric, tell them, please enter a number. That number needs to be between 1 and 12. You can check and see if something is a character. You can see if something is white space. The one thing you have to realize is sometimes if you have a 9, it's the number 9. But if you have a string that says hello 9, that 9 is actually a character who looks like the number 9. So you need to realize that a string 9 or a character 9 is different than the numeric value 9. We'll probably down the road deal with that a little more. So here you're asking for a salary. If they input something that is not numeric, then you can tell them that's invalid, try again. And loop through until they actually give you a numeric salary. At that point, you can consider the salary at least somewhat validated and continue on down with the rest of your program. The other thing is you might check them for reasonableness. I was thinking about this when I was talking about the previous flowchart. If you ask what somebody's salary is and you put in $1 billion, there's probably nobody, at least in this time frame, that gets paid $1 billion a year or $1 billion a month. So you might try to catch that. The other thing you should do, and it's called defensive programming, is think about all the things the users might do wrong and then put code to counteract that, tell them what you need, validate the data, etc. So this is just a summary of comparing selection and looping. It should be fairly straightforward, and we talked about this. Here we're doing the same thing over and over again. If we wanted to process 1,000 records, this flowchart would have 3,000 items on it. So if you're doing the same thing over and over again and testing for the same conditions, then obviously you're going to want to do this with a loop. And in this case, you want to loop while we're not at end of file. So here is the more efficient, structured, with a loop, including priming of the loop, correct way to represent this in a flowchart and then actually code it in your program. So that finishes up this chapter when we discussed loops.